equations similar to planning a vacation.
I have no idea if this is working. Should be.
I'm going to go down and get a box.
Okay. How is working with systems similar to planning a vacation? Is this reflection more about the vacation or the system? It's more about the system. You can picture the place. So how are they connected? Giving you a minute. 2 minutes. At your pods, each person share out. Wait till everybody's ready to go.
What did you put? I had a really good, I had a really good train of thought. Okay, what's yours, Hannah?
Working with six. Okay, it's not that cheesy.
Okay, mine's
What do you
really
have?
cheesy.
Good. Good.
Eric shared mine. Jacob shared his. Yeah, he did.
Well, let's see what you got.
I heard him.
What do you have?
Okay, working with system equations is like planning a vacation because you first have to figure out what you're going to do, and then you have to go step by step.
Fair enough. Kaufman?
Equations are like planning a vacation because there is more than one way to do it and it will take time to do.
Fair enough. Shem?
Yeah, forget that last part. I can't remember it. Anyway, when you are working with systems, you need to plug in numbers for X and Y. If you're planning a vacation, you need to plug in activities and see if you can, like, if they work and you can do it.
Fair enough. Danny? You're quiet now? When are you ever quiet? What do you have? Come on.
I didn't say how to like. I kind of made up a problem.
Fair enough. What do you have? That's fine.
I said you can use system equations for like airplane tickets. Like if 12 and under people cost $900 and older than that is like $750, you could like.
Budgeting and systems work hand in hand, so don't kid yourself. You're okay. Don't be shy. Tell me, how are systems similar to planning a vacation, Jack Johnson? Find out all the unknowns, right? What are you working with in this situation? What are the unknowns? What are the variables? Mike?
You have to figure out what you're going to do, and then you put things together.
Figure out what you're going to do. What's your plan? And then put those things, those plans together. Trev?
They both require you to think ahead.
You do have to think ahead. Unless you're somehow able to just jump in the car, jump on the plane, and go. You got to be a plan from the start. Maddie?
You go there, and then you go back home by like checking.
Like that. So go through the process, reflecting upon where you've been. You're getting very deep here. Wow, you're like poets. Timmy?
You have to solve like see what the attachments. You have to plan all parts of it.
Break them up. Chunk them into small parts, right? Anything else you want to share? Other ideas?
You have a budget and there's a cost. The cost is X and Y, while the budget equals X plus Y.
Uh-huh. And Daniel's kind of getting the same area there too, Pat, thinking about how a system can work with vacation planning, for instance. Balancing costs. You okay? What'd you say?
What?
What'd you say?
English, please.
English.
English for you.
Oh, he's fine. No, I liked it, Pat. At the same time, what's your objective? Where are you trying to get to? What's the objective of the vacation? If you're a parent and you have kids, is the vacation for the parent or for the kids usually? Hopefully the family. So, thinking through today, back together, thinking through the process, what is the ultimate objective? Who's been to Betty Jane's? Do they order in their pre-made chocolates or do they make their own chocolates? They make their own. From what?
Cocoa powder. Cocoa beans. Chips.
Fair enough. That they're creating chocolate from previously made products. They're taking one item to make another. Like a car. A car doesn't just come assembled, does it? Does it come with every single nut and bolt separate? No. Oftentimes, one part of the car is assembled here, another part's assembled here, then here. Those things come together. Today, assembling some chocolates. This actually, giving props to Mr. Reese. You know who Mr. Reese is?
Yes.
He's one of our instructional coaches. Yep, he wasn't here before. Mr. Reese used to work at Washington, 8th grade math, good buddy of mine. I got this idea from him, this problem from him, so giving him the credit he deserves. This problem, I'll read it to you, and then in your selected teams, you find the approach. What is the question asking of you? Where are you trying to get to? And I'll stop you in a little bit, and I'll see where you're at. We'll clarify along the way. But I'm going to kind of observe and monitor and look for some patterns in your thinking. It says, and feel free to watch on your paper as well.
Mother Goose's chocolate sells the following amounts of each chocolate mixture. 60 pounds of Father Bear bars costing $15.
These kind of chocolate contains different amount of the two different types of chocolates. Bittersweet chips, which cost them 90 cents per pound. 90 cents per pound.
How much are you using in each mixture? For the Mother Bear, Baby Bear, how much of the bittersweet, how much of the ultra sweet goes into it? Notice down below it's giving you a little table. Allows you to organize your thinking, your thoughts, your results. But from there, your goal is to get to that point. As a team, working together, or on your own if you need to, how are you going to get there? How are you going to find that information? How many pounds of each kind of chocolate to make these batches? And how many total pounds of each type of chip must we buy? Questions? The room is yours. Danny, you seen Zakia? Center. Let's stick. Hey, dig your equations here. Good setup, okay? I need to see how you're getting to this point, okay? I see you're solving, trying to use substitution here, but where did you go from here? I need to see that process, okay?
Alright.
Mr. Birch,
Yes, sir.
did you see my quiz yesterday?
I did find it, yeah. I got my pile here. I'll be right back to you, okay?
No, there's sweet chips. How many?
Okay, in that case then, the balance here is a little bit off, okay? I do want to help you clarify this.
I got it one off.
Yeah. Thank you, Trev. You rocked it. Nice job. What do you think? Well, because there's 3 scenarios, right?
Yeah, for each.
What is it we're trying to find ultimately?
How many pounds it takes? Well, like, you need to find out. I don't even know what I'm going to say.
Just words coming out of your mouth?
Yeah.
Ultimately,
We have to find out
what does number 1 say?
how many pounds of each type of chips are needed to make each batch of bars sweet mint.
Aha. Our goal is to find out how many pounds of each type of chip between ultra sweet and bittersweet. How many pounds of each, correct? So in that capacity, yeah, there's Father Bear, yeah, there's Mother Bear, and yes, there's Baby Bear. But those 3 products operate independently, right? Does the Mother Bear bar affect the Father Bear bar? No, they're different items, okay? So in that realm then, think about this. You have the amount of poundage of the chocolate, right? You have the cost for that chocolate, correct? Yeah. How can that balance together given those 2 pieces of information? The amount, the cost. Is a batch 12?
Yes.
Clarify that, please. I don't know. A batch is whatever is required to make this.
Okay, so I'm not sure if we're on the right track, but we simplify the 1 pound so we can make it the same as this one to make it simpler.
Let me help clarify one thing here first. What is B?
B is Father Bear bars.
Okay, what is C?
The bittersweet chips.
Okay.
And I'm not sure if it equals 12 or not.
Well, look at number 1, the bottom part here.
Yeah?
Ultimately, what's your goal?
These, or should it be Father Bear, Mother
Find
Bear?
how many chips that made bears make.
Ultra and bittersweet. Okay. Now, the bear, Mother Bear, Baby Bear. Do those products occur independently? You know, I don't know, whatever, almond, whatever, chocolate covered almonds, they happen separately, but they all use different parts of chocolate. Father Bear, what kind of chocolate? Bitter, sweet, and ultra sweet. The bitter. Lizzie, just need to solve this one, find the y-intercept. I got your note. Happy to work with you, okay? Just make sure you find me. Okay.
Find like U by itself or V by itself.
You combine these, right?
So bitter is
Luke, Careful on this one. Kind of flip some things, okay? What's your starting value?
2x, 22.
What's your starting value, though? What's your y-intercept? -3. What's your slope?
2x.
Okay, so down here, point upward. You solved it for y, right? What's your intercept?
5.
What you had? What's your slope?
-2x.
Okay, let's fix that graph. And then down here, just a goofy mistake. You said that 2 minus 18 gave you a -18. Just 3 off, okay? Those little fixes and you're good to go. Okay. So, let's solve. And x, right? Solve for x.
So if they all match up.
That's a great start. Okay, looks solid. That's cost, right? Else is missing. Exactly.
Bittersweet and ultra.
Pile of bitter, right? Pile of ultra. Eddie, this was almost perfect. All that you missed here was
Okay.
negative slope. That was it. Okay.
plus
Do it
y.
real fast for me,
I'm
okay?
gonna make the first equation negative.
Wait, Mr. Burke. Will you check this to see if we're on the right path? This looks right.
I seriously said what we were supposed to do, and like everyone.
No, she said, no, we have 2 equations.
Is that because you're the youngest?
No, I'm the youngest. Wait, how old are you?
I'm Addie's youngest because she said
Okay. Well, help me out here. If these are our equations, first of all, define our variables. What do x and y stand for?
This is the ultra. No, this is the thing, and that's the ultra.
That's the thing, and this is the other. So defining our variables, right? X is,
Bittersweet.
y is. Make sure we define that, okay? So you recall. Okay. Make sure we're referencing that. So the bottom equation, what is this telling you?
That's how many pounds.
All right.
Now his own words.
You go.
All right. So it basically means bittersweet plus ultra-sweet has to eat 16 pounds. So basically, there has to be something equal 16 pounds.
Pounds plus pounds is 16?
Yeah.
Yeah.
16 pounds.
X is not just bittersweet. And this is not just ultra sweet. It's the amount. Okay? How much do we actually have? So what does this equation then mean? Up top.
Oh wait, that's wrong. There we go.
But that's for one of them.
What do you mean that?
For the point.
The X is for bittersweet and the Y is for ultra sweet. And you have to like have a certain amount of the to get 50.
What is that 0.9?
It is the cost of bittersweet.
That's the cost, right? And what is X then?
How many you need to have.
Yeah, if it's 90 cents per pound, then X is the number of pounds. How much for ultra sweet?
120.
$1.20.
1.20.
$1.20 for. Sir, dear. Thank you for asking. sync up with your y values here. That 3.6 was a little bit off, okay? I want you to grab GeoGebra. I want you to grab them all at once. Okay. What did you see, okay? Pencils down.
Why?
And 2 more seconds for you. Pencils down. Please.
Pencils down.
You're so well behaved.
I don't want to work. I don't lose my train of thought.
This is great. She's so anxious to get back to math. As far as me turning you into nerds for that close, Danny.
I love math.
And a girl. Time travel back to our conversation from earlier, talking about planning a vacation, right? Yep. Our ultimate goal here, planning a vacation, is to do what?
Go on a vacation.
To just go on a vacation? You just have fun with just randomness? Creating a plan, right? With a certain destination. Vacation has a certain destination, certain plans. In this situation, quite similar. Establishing a plan from the start. And what does that plan have to start with? A budget, maybe. Vacation, how much money you have to work with. The provided information, where you're going, how long it takes to get there. Here, instead of a budget and a timeline, the solid information. We're comparing what 2 items in this scenario? Pounds of chips. Pounds of what? Pounds of bittersweet. Pounds of ultra sweet. Betty Jane's. There's Gremlins. What else is there? Caramel apples. What else? Truffles?
No.
They're separate, aren't they?
Yes.
So the bear bars influence the mother bear bars, influence the baby bear bars. They occur separately. Bittersweet, ultra-sweet, and context of what? Pounds? And money and cost, Chase. That a handful of bittersweet and a handful of ultra-sweet have to add up to how many pounds? 16. But the cost for that pile of ultra and that cost of the pile of bitter
15.
is $15. So how does this all balance together? You made a plan for your vacation, right? How do you plan to solve? How do you plan to solve this? You made a system and then what?
You solve it.
How?
I do substitution, so like.
Substitution, says Danny. Who else uses substitution? Does it work? Yeah. Should. Elimination fans? Pat, what you doing?
Squad.
To do what? He's going to see how the graph compares. Is the graph an essential and appropriate tool? Yeah. So Chase, is the graph itself, thinking about our standards of practice, is the graph an appropriate tool in this scenario? Yes. Will the graph lend itself to an approximate or an exact value?
Yes.
He's going to find out. I'll come back to you in a minute, okay? Keep going. show you a cool feature in a second here as well, okay? 0.9. Mouse thing ready. Right now, this is called general form or parametric form. You do that. What is it tells you the starting value and tells you what else. Right away. It's a little feature there, okay? What's your solution? You know what you can do? Let's look through these, okay? What do you see there? Down, 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 down. Intersect. Come over. Right there. What did it give you? 14 and a guy. I'm going to use that in a few minutes, okay? Okay. 1 Cool. Are you okay there? Giggle fits back here. You're going to have some work to do tonight.
I don't know why. 0.9x and then divide by 0.3.
You have no idea what you're doing.
I think it's 0.3.
It wasn't that bad.
Actually, I'm not. What if I was? How would you feel?
Oh, you got that fixed? Did you have 85 before?
I had 71.
71. Oh, okay. Okay.
That happens. It's weird.
What's your name?
That eye's blue, that eye's green, but it's really hard to tell.
All right.
My dad's friend has one really, really dark eye and one light blue eye. It's kind of scary.
It's here. How you doing? Where's your work? What's your methodology? You feeling better about this stuff?
Yeah. It's on this page.
Gotcha. Can I borrow this?
Okay.
Do you mind? You want to keep doodling? Do you want me to rip this page out, or do you want to rip that page out? Okay.
The second one? You wanted to 160. Get them all? Sweet. Do me a favor. Can you turn off points A, B, and C as well? Let's turn them all off to start with, okay? And then I'm going to go through them one at a time here, okay? Thank you, sir. All right. I don't have 5 minutes. I'm sorry. Eyes and ears. You know I'm pretty flexible, right?
Yes.
So if you need more than just tonight to work this process, is that okay?
Yeah.
Yes, that's fine. But then do me the favor, and your neighbors the favor, respectfulness of adhering to the conversation. I can do math all day long and try to learn from the actual symbolic manipulation. But I found out a long time ago, I learn most when I listen to others and I watch what they're doing and I see their work. Working with Mr. Meyer, Mrs. Frummelt, Rigdon, Duvey, Ms. Palm, taking classes with them and seeing how they solve problems, that's what opens my eyes. So my request of you right now is, I know you want to finish this task right now. You'll be okay. Please drop the pencils, drop the pens. Let's come together for this conversation. Let me see your eyes. Yeah, all 4 colors. Try to resist. If you're going to be tempted to write down, just take that pencil in. In the words of Frozen, let it. All right. In this scenario, up top here, this kiddo, fantastic first step. We did what here? Define the variables. What is x? What is y? Up the equation. What is the equation right here telling us? The cost. The cost of bittersweet, the cost of ultra. Focuses on what? Number of pounds, the amount. And this kiddo used what method to solve? Multiple 1.2 negative to cancel out the y's. We solve for x. Solving for x allows us to find our that equation is different. Point on x plus 1.2y equals 27. X plus y is 25 because the values for mother bear bars are different than father bear. Kiddo finds in this case that x is 10 and y is 15. And then for baby bear bars, x, bittersweet, came out to be 20. Ultra sweet also 20. I asked Pat to jump onto his computer, or a computer I guess, and to graph these things. The question being, once again, what's the appropriate methodology? Is it best to use substitution, elimination, a table, a graph? What is going to work here? Does it matter? No. We'll find out. Were your equations approximate there, Stick, Luke, or were they exact? Exact. They were exact values. 14, 2, 10, 15, 20, and 20, exact values. Do you suppose that these are going to give us exact or approximates? What's our goal here? Exact or approximate? Exact. You're going to want a pretty exact amount. If you're making a recipe over and over and over, you don't want to alter the recipe. You want the same thing each time. And so Pat simply typed in the equations. Father bear bars. What do you see here? There's an intersection point. The intersection point looks to be roughly where? You say 14 and 2, perhaps? 14 and 2? What Pat did was found the intersection point right there, which is 14 and 2. Approximate or exact? Exact. Mother bear bars. Put in one equation, put in the other. Click. Approximate or exact? Let's check it out. Right there is, in fact, 10 and 15. And one more time through, the baby bear bar. Right there, which Pat says 2020. Exact amounts. I want you to how do I approach it? What, and then what might my next steps be? If you're planning a vacation, you don't know what you're going to do.
Figure it out.
No. Hold up. Tomorrow, taking this to a slightly higher level. So, my request, come back. If you need more time, what do?
Ask.
Talk to me, but I want to see your as of now. Again, writing and solving systems, what's the best approach? Fantastic work today. Bring him tomorrow, okay? Sooner the better. Mr. Lass was trying to videotape me during class today.
That review sheet up there, do you have any of those extra ones?
Sign up and I'll make a copy.
Do you have to print another one out?
Hold up there, Maddie.
My name's already up there.
Oh. If you want that review sheet, sign up. I'll make copies tonight or tomorrow, Matthew. Okay? Wait for the bell. Hold up. Thank you, sir. Appreciate it.
Do you know what? Just say yes or no. Do you know what? Sure. Okay, then do you know what? I'm gonna steal your spot. Thanks.
Oh dear.
Eddie,